Hello, good afternoon. Thank you for coming back after the lunch. You can see the audience size has been slightly reduced. Fully, they are still outside. Okay, so this session is very important because it's just right after lunch. So we count on the next three presenters, I think starting with Dr. Kok Wah Yu and the rest of the two presenters to keep the audience awake. Okay, so make sure the presentation is sweet and attractive. So welcome to session 3. This is another round for ICT for environment protections and disaster prevention, second session. So I'm pleased to welcome Dr. Kok Wah Yu to present on the title ICT-driven water quality monitoring systems. I'll give the details to him. Okay, over to you.
Okay, so good afternoon again, and thank you to the chairman. And I know that it's after lunch, so I'll try my best to make it simple and clear so that we'll finish much more earlier so that you can relax after that. So my name is Dr. Yu. I'm from University of Science Malaysia, and the title of the project is the ICT-driven water quality monitoring system, enhancing pollution and connectivity in environmental assessment. So pertaining to this project, we have the challenges in terms of trying to measure water quality. So water is quite an important resource, and there's a need demanding to measure or monitor the water quality. And we can have different type of water quality measurement. For example, we have turbidity, we have the TDS, we have the EC, we have the dissolved oxygen. And for example, that for the water quality, we have IoT sensor, and also we have the commercial sensor. And we can compare in terms of the pricing of the IoT system or the sensor. We can take turbidity, it's like USD 20, and commercial sensor is like 6,000. So we can see the big differences. And in terms of the water quality sensor, we can take a look at the trend on the market size is increasing throughout the years, and for last year alone is 5.4 billion. And for turbidity sensor, it captures a portion of the market. So in terms of the challenges, the first challenge is that, of course, that we have IoT sensor, but in terms of try to adopt that, also try to implement that, we have issue pertaining to the reliability and also the position. So we have tested it and compared with the commercial unit, and the result is not that good. So the first one is try to improve the position and also try to improve the reliability. The second one, when we try to implement IoT system, we have problem in terms of the connectivity. So connectivity is an issue when we cannot pass the data from the device to the server. So to address these two challenges, we have two objectives. One is the position, try to improve the position and also performance of the IoT-based sensor. Second one is to try to improve the data connectivity. So the proposed idea is that conventionally we use the Rayleigh scattering formula, and using that formula, that one is being used for the sensor, IoT sensor. What we try to implement is that we try to use machine learning, try to complement that. So what we do is that we can have pre-processing where we filter the noise and we did some data normalization, and we use some AI model to train it and try to improve the prediction of it. So there's some performance metric that we try to do, try to gauge it, like MAE, MSE, ISE, and also R2. So the model that probably we can use is the INN model. So initially we use INN model. And we can also try to incorporate the image processing. This is one of the trial that we did with a different background. So we have a white background orange background, blue one, yellow, and also a cross-sign background. So for different NTU standard, we can see the differences in terms of the picture. So we can train AI model, and we use CNN model. The accuracy is like 88.9%, so it's quite encouraging. So that one is the training losses. So for the objective number 2, we try to improve in terms of the data connectivity. So what we try to do or propose is that we use D2D technology, try to communicate between device to device, and try to pass the data from the relay to the server using LoRaWAN. So from the server, we can upload to the real-time monitoring using the Node-RED platform. So in terms of the scientific and also technological outcome, the first thing is that we try to improve the IoT sensor improvement or advancement. So in terms of that, we try to improve the formulation and try to cater with the AI model that we can predict it much more better. So we have the problem in terms of trying to predict closer to what being predicted using commercial unit. Second one, try to improve the IoT system network. So we have problem in urban, also in rural area, where we have buildings and we have trees. So passing the information using IoT device to device is a challenge. So the second one is to improve it using the D2D technology. So we have expert in terms of D2D. We can implement that and we try to improve the system. The third one is to have longitudinal study and modeling. So that part with the system, we are trying to focus on doing some meaningful study to try to improve industry inside ASEAN. Is much more related or rely to the climate changes, also the effect from the environment. So that one, if we can try to improve the system, try to adopt that, that one can be a useful tool. So this one is in terms of the societal impact and also collaborative impact. So in terms of collaborative impact, we are looking into the aquaculture partner. So we have aquaculture partner that have the fish breeder, also crab breeder, and also in terms of the environmental agency, we have also can try to engage on the fishery department. So that one can be helpful for them. So this one is in terms of the scientific outcome. So the formulation, new formulation or new model for the AI, and also try to enhance the in terms of the IoT system network. So for the collaborative partnership, there are several grants that we try to target on. So the first one, we have made application to the UK Research and Innovation Grant involving several partners from UK, Vietnam, and also Malaysia. So there's several partners that we have submitted the proposal. So the proposal is to try to improve the IoT system, try to adopt that for mud crab breeder. So mud crab also very sensitive towards the water quality. So you have to be measured or inside the range of the certain standard. So second one is to apply for the Royal Academy of Engineering grant. We also have partner from TDTU, that one's from Vietnam. And probably we can try to apply for PPI with National Yang Ming Chiao Tung University from Taiwan. So this one is the conclusion remark from the proposal. So I won't go through it. If let's say that you need clarification, I'll try to clarify on that terms. Okay, thank you. So if you have any suggestion or feedback, I would address that.
Any questions from the floor? Yes, over there on the left.
Okay, so thank you so much, sir, for the interesting presentation. I'm interested in the LoRaWAN the module that you use for the wireless communication. So could you tell us more, what is the communication range for that LoRa module? Because like some of my students have did some project with that module, and they said that the provided coverage range does not really meet the provided guidelines. So they mentioned that in terms of coverage range, the distance should be like lesser than the given data set. So can you share some experience for your implemented project? Yeah.
Okay, so communication in terms of LoRaWAN is much more in terms of long-range communication. But normally, in terms of communication, when we try to pass the data from a place to a place, you're affected by the obstacle. So normally, if let's say that we are applying on an open field or on the sea, so that one is much more easier where you don't have any blockage. But in terms of communication, I think I'm not myself as the communication expert, but what I know from them is that when you have obstacle or you have surfaces, you have reflection in terms of that obstacle. So it's not that easy to implement it, although that we can have implementation of LoRaWAN, but depend on the situation on site. So depend on that. But for this proposal, we try to adopt the D2D technology from NICT. What the benefit of the D2D is that it's much more lower, I can say lower spec, but they have a higher rate of the data transfer. So lower spec meaning to say that we have lower cost and also higher rate in terms of data transfer. So implementation is about costing as well. So we cannot have everything to be as costly as possible. We try to adopt a lower cost alternative so that it can be applicable for those normal applications. So normally for aquaculture, they prefer to have a low cost system. So thank you.
Thank you for your presentation. This is a very good project working on the offset and noise reduction for the sensors measurement. I think it's very good and can be implemented for all the countries, I would say. Yeah. Just a question on how you quantify or identify if there is an error in terms of measurement. Do you have any guidelines or anything that would guide you, okay, now there is a problem, then you have to correct it also? Yes.
Okay, yeah, thanks for the question. We have tested several sensors, normally for IoT sensor. Normally, IoT sensor, they are not that reliable. And the prediction that we made by IoT sensor is offset by a lot, but not all type of the sensor. For example, turbidity sensor will have deviation more than 100%. And it's quite sensitive in the sense that it's been affected by the outdoor light. So if, let's say, it's daytime, so you're affected. So normally we have to have an enclosure, put it inside, then we can have a better estimation. And also for the turbidity sensor that we have for the IoT, it fluctuates a lot. So it's pertaining to the noise. So probably the machine learning can be helpful in terms of try to cancel out the noise by learning the trend. So that's the intention of the project. But of course, we have partners. We are welcoming other partners that have interest in this project. So thank you.
Yeah, hi. We have been playing with this sensor quite a while. Everyone playing with the industry sensor. So we realized that we agree with you, what IoT sensor actually is quite sensitive as well as unpredictable and unreliable, and can be subject to change to environments, even like temperature changes. For a pH sensor, it will change really much. But my questions back to you is that how you validate that your AI model, your AI optimizations of your IoT sensors is the real reading of the water qualities, because even industrial sensor itself, the quality, the reliability itself is difficult to control.
Okay, so thank you for the question. We always acknowledge that we have errors in terms of the sensor. So even that we have 2 commercial units of the sensor, there's still deviation between that two. So in terms of trying to make sure that the prediction by the IoT sensor is much more within the range of the satisfactory. So we have to do some calibration. Sometimes it's the offset calibration, and sometimes it's the white noise or the noise calibration. So there's certain things procedure that we need to do, but comparison in terms of try to compare with a commercial unit, that one is the important processor. So as long as we've done that probably in the long term, so probably for a few weeks or probably for a month. So if that sensor, when we deploy, is much more convincing, so it can deploy in terms of the real application. But still, there's a process to work on that. So thank you.
Just a quick comment on it. I think what you just said, I think is quite true in a way. But however, like in terms of even like 3 months later, your whole sensor will need recalibrations as already. So I don't know how you're going to use the AI optimization algorithms to actually to say, okay, this should be within the range of acceptable for the water, but the water quality keep on changing as well. But there's something that you have to take into consideration.
Yeah, okay. So in terms of the commercial unit as well, we need to make sure the calibration is there. For example, that there's biofouling. So biofouling can affect the sensor as well. So normally we need to clean it, but in terms of the IoT sensor, what we try to do is try to calibrate it, try to implement the AI model. Some of the IoT sensor, they are based on some formulation to predict their outcome. So if we can change the formulation to have a better prediction, that one could be a consistent. And if we can adopt that and try to apply that, for example, for turbidity sensor, it can have good benefit throughout the Asian region. So I think that one is a real issue, but we have to address that during the project. So thank you again.
Okay, you made it just nice. I think that's why we are all here. Questions come one after another. I think that is where we need to still continue discussion and hopefully can get together into a project so you can seriously work on it. Thank you for your presentation. Okay, now I would like to welcome the second presenter from University of Laos. Okay, the presentation title is Wastewater Management and Monitoring System in Special Economic Zone using IoT and Smart System Approaches. So let's welcome Dr. Kamla.
My apologies if my voice is unclear because I'm not feeling well when I arrived at Phnom Penh. First of all, thank you for the chair and audience. Today I'm delighted to be here to present my current research under the topic of wastewater management and monitoring system in special economic zone using IoT and smart system approach. Nowadays you may know that we have a lot of business operation based on economic development zone because we have a lot of activity in terms of industry and some activity in so sorry because I'm not feeling well today, so I cannot control a little bit. So, nowadays you may know that we have a lot of activity based on business operation, especially for economic development zone. They also have some activity for their operation, and of course they also have many kind of activity in terms of environmental impact. So in our country, we also have some kind like this, and then they also have some. Okay, thank you so much. In our country, we also have a lot of economic zone to operate for the business and in terms of industry or in terms of sort of factory. And then they also have activity that regard to the environmental impact. So now the answer, we need to follow our regulation to do some business studies for the environmental monitoring. So now and then we try to provide some technology to propose for the wastewater and to improve the water quality at the for the special economic zone. Sorry. The purpose of our project is to develop a smart monitoring system to provide some issue to handle with some issue for the water quality and provide some accurate and real-time data for wastewater impact, reduce negative effect and for social environment, and also to assist organization for practice water quality responsibility and contribute to the broader sustainable development goal. We have combined some technology that call IoT and smart system using hardware with the excellent sensors, prototype platform, and smart device, especially for water quality sensors to monitor some environment parameters, especially for water quality, example for pH or for dissolved oxygen or ORP or so on. And together with this one, we also work for prototype for data analysis and integrate with other system, especially for cloud-based service. Here is our proposed method that we use some sensors, especially we use water quality sensor to monitor the water quality for real-time monitoring and real-time response for the monitoring using core controller through wireless communication module. And then we have some real-time response using data processing and data sharing. And then we will have some notification to the user when they have some irregular situation that happen to the around the area of the wastewater. To help that one, we not just only provide for the water quality, but we also provide for the other environmental parameters. Example, we provide for air quality, soil quality, and noise level around special economic zone to make sure that our system is work for all aspects of the environmental impact assessment. And then we will have some application that we will develop for the system using web application and mobile application to monitor in real time. Yeah, for the impact, yeah, of course, we will have some many impact for the business operator who need to pay attention on wastewater and environment issue to make sure that they can have some responsibility for the environmental protection. On the other hand, we also have some sustainable development protects biodiversity around the area of the water sources, and that come from the factory or from the industry around the economic zone. Yeah. And then we also have some early warning system that facilitate the user or the owner of the business operator that they can do some action for the environmental protection. For the outcome, we will have some real-time monitoring system to track the status and treatment process by providing visualization and dashboard to monitor for all aspects of the environmental parameters. Yeah. Also, to be able to provide customized reports such as daily, weekly, monthly, yearly, because in our country, together with your business operation, you also need to do the activity that we call environmental impact assessment together with your operation to make sure that your industry or your company that not too much effect to the environment, or at least you need to have some issue or some concern to handle with the issue of the environmental issues. Yeah. Also, we have some new technology for the company that they can provide, and then they can have some system to improve the quality of the environmental impact assessment. Yeah. For the conclusion, we also, finally we will have some system that we call smart monitoring system to monitor and manage the wastewater for the environmental impact, and to provide the system for the business operator to make sure that they can have some responsibility for the environmental and the wastewater management as well. Yeah. Okay, maybe that's all for my presentation. Thank you so much, and so sorry for your inconvenience.
So any questions from the floor? Suggestions, comments?
Yes, I think this is a very good presentation. Just want to ask, what is the current practice right now in terms of the water management, wastewater management in Laos? And do you want to implement your systems nationwide? And how you plan to deploy this with the ministry or maybe people involved?
Yeah, actually in our country now we do some water treatment as like a traditional method, and they use some use some chemical or something to do some water sources from the factory, and before send them to the nature or something like that, and then they need to have some laboratory tests first. But our system is just real-time responding, and then we will have like a sensor to test immediately, and then you will know immediately from the result that if there is a lower standard or higher value or something, and or in the critical level. So the system will know immediately, and then it will have some like provide real-time responding. Yes, and then I think this technology or this system will help us a lot, because if we have some kind of technology to help us for the monitoring or management, and then it will be faster and easier to handle with the issue of the wastewater problems. Okay, thank you.
Okay, you still have 5 more minutes. You still have chance to attract people to join your projects. So maybe you want to speak more on any aspect that you think is worth to get the audience to join your team, to work together on some issues. Any things you want to highlight? I guess there's no other question.
Yeah, actually, for this project, for this project is under implementation. That we have some collaboration with our team, and then with the some company in our country to conduct and implement the project. And yeah, now we already have some research, and then we already provide some solution to the company. Then some company already agree with us to provide some this kind of solution for them, and then also quite interesting because some economic zone they still have only like a traditional methods for wastewater management, and so we provide this solution for them, and then hopefully that after we finish everything for our complete system, we will have some testing for at least one location in our country first, and then to see the result, and then to have some report, and then we will have some data collection from the real-time responding from the system, and then we will have some like to see and to know the quality of the water of our country from from now to the future, and see what will happen, and then how to handle together, and then how to change the behavior of the wastewater management as well. Yes.
One more question.
Yeah, I think Dr. Chung raised a very good point, how you can convince others. That was the question earlier, saying that this waste management system is already in place for all the country, meaning all the system is working very well. That's why we are living in a very good quality of life. And my question was, how would you convince, that the system right now is not working well, and this is the system that they should adopt? And now this is the case of Laos. How about the rest of the Asian country? If you were to submit this into a proposal later on, would you want to have a comment on this? You got my point, right?
Actually, yeah, I'm not really sure about this technology for the other country, because we have some research paper or journal. They also have some kind like this as well. But the initial idea for us, for our team to implement this one, we focus on environmental impact assessment based on our government regulation that they need some action for the environmental protection. So in our country, I have experience like to work with some organization about environmental. They use some kind of like a traditional style to have some laboratory testing or something like that. But we try to propose them with the modern technology and real-time, accurate, and maybe high precision of the report or notification, and then they have some alert to the business operator to know they have like a over over their standard or not. because or maybe lower standard from like we have some parameter help them a lot for accuracy and real-time responding. Because if in our country, if we need to do something, we need to take some sample to test at the laboratory and then take times. But we have this one, we have this technology, and then we have immediately responding. So we have some real-time report as well. Yes.
Okay, thank you. Yeah, thank you.
Okay.
Thank you for the presentation.
Thank you so much, and so sorry.
No problem. Okay, now it's time for the third presenters from Cambodia. Cambodia itself. Okay, yeah. So the title of the presentation is Leveraging AI Integrated IoT Solutions for Real-Time Solid Waste Monitoring and Classification. So we welcome Dr. Lee Ho. Lee Ho.
Yes.
No.
Yeah.
Okay.
Okay, so
Please.
thank you, Chair, and good afternoon, everyone. My name is Lee Ho No, a lecturer researcher from the Cambodia Academy of Digital Technology, CADT. So today, really my great honor to present you with my initial research topic on leveraging AI integrated IoT solution for real-time solid waste monitoring and classification. So, as you may know that waste management is a crucial issue maybe for every country, I guess, because according to the World Bank record, they mentioned that the global waste will be increased by 70% from the current level by 2050. And the waste amount will be accounted for 3.4 billion tons. So this is really a huge amount of waste that have been generated, and it needs urgent action to tackle on this issue. So as you may know that with the evolving technologies, nowadays modern cities are facing a significant environmental challenge in terms of waste collection and disposal. So according to the ASEAN Development Bank survey on 2020, several cities like Manila, Jakarta, Kuala Lumpur, Bangkok, and Hanoi, they have a lot of waste generation. And also in Cambodia, according to the report in 2021 from the Obor capital, they mentioned that the waste generation for Cambodia in Phnom Penh alone is around 1 million tons. And the amount will be expected to be more than double by 2030. So the amount is a hugely increase. And we have two main dam sites in the city, and they expect to reach out their capacity. So a proper way of managing those waste is critical. And maybe, as you may know, with the existing AI or IoT solution, we can mitigate this technology to improve the monitoring and management for the waste. So specifically in Cambodia, we found out three main key issues. So based on our observation, but this is specifically for Cambodia. I'm not sure for the other Asian country. But what we observe here is that currently the system is we have no real-time monitoring system. So it's the waste company, they collected the waste from the other region, and they use the traditional way or insufficient scheduling. So this may lead to the improper way of collection and management the waste properly, because in some area the market, so the waste generation is a little bit high, and without collection on the waste on time, the waste amount will be overthrown, and this will damage to the environmental aspect and also maybe a health issue too. So the third issue is about the insufficient system for waste segregation. So as you may know, Cambodia people here, currently they are, the way of disposal the waste is just getting everything just in one bag and then they just throw away. So we don't really have a proper way of segregating those waste into recycle or non-recycled waste type. So this will also be a challenging issue for the management too. So the objective for this research will be like trying to develop an IoT integrated system that can be provide a real-time monitoring system. So we can call it a smart bin that we put some sensor specifically to the bin collection for the trash, and then they can alert the status of the trash whether it is overthrown or it needs some certain action to take hold on, like at certain moment. And as I mentioned, also the collecting scheduling is insufficient. So without proper notification in terms of the urgency of the waste collection, the waste company, like the collector, would not have enough information in order to go and take the trash in time. So the problem of overthrown waste will be occur. So we want to also provide a real-time notification for waste status collection, and also provide an optimized waste collection route. So in Cambodia, we do have some problem with the traffic jam too. So it's like if we can monitor or determine the specific area to be collected for the waste, we can optimize the waste collection route, and this will also save both the collection efficiency and also cost of waste collection process. And the other one is about the waste segregation, that we want to also implement the waste classification assistant at the dump site. So as I mentioned, people usually just throw away everything into one bag, and they don't really care about how the management will do with classifying those stuff and managing the waste efficiently. So we want to have maybe we call it an AI-assisted solution that can be used to classify several types of waste, but currently in this project we focus on only solid waste. So maybe we have several types of waste, such as the bottle, plastic bottle, the food waste, and some other stuff. So this will be counted for the recycled and non-recycled waste type. So actually there are several existing research papers that have been done on the IoT integrated waste monitoring system, and we have some research about that too. And the way it used to implement for the project is enable real-time waste monitoring. So this will be involved with the IoT system. So the other task will be the classification. So this will be involved with some AI or machine learning technique that is suitable for the problem specifically. And the mechanism for the IoT deployment will be a suitable sensor will be placed on the bin, like the collection site, and the information on the level of trash field will be sent to the monitoring center, and also the location of the waste will be monitored too. So once we get those kind of information, at the monitoring center, we can trace on the status and what action to be taken on in terms of waste collection activity. So as I mentioned, maybe the level of implementation will be started from the hardware implementation. So this will involve with the IoT placement, the module placement with the bin. We call it a smart bin, where we can retrieve the information on the waste level, and also a monitoring center that track those status efficiently. And the information should be transferred to the cloud, and the cloud that can be further processed in terms of waste optimization, collection optimization, and also monitoring the status too. And another thing is a GPS module will be embedded into the smart bin too, in order to track the location, and this will assist when we reach the waste collection route optimization. Okay. So about the connectivity, for the initial prototype implementation, we're planning to use the ESP32 microcontroller module for prototyping, and also we use the LoRaWAN wireless technology for data transmission. And for the classification, so this will be done separately. So when we gather all those trash, the trash will be put into one management side, that they have the ability to classify the waste using some, currently we are focusing on the convolutional neural network, the CNN model, in order to classify the type of waste. And we also have some data set that is available on the internet in order to to recognize and to identify type of trust. And this should be working effectively, but I mean, in order to make it really suitable for the implementation for Cambodia case, some other data set would be needed and then to be pre-processed before the actual implementation. But just to mention again, the IoT part and the machine learning model for the classification would be done separately. So for the impact of the project, so as I mentioned, we want to enable the real-time data classification and tracking. So in order to track the status of the trash bin, whether it is overthrown or not, or we need to take the trash collector should be collected or not. So we need the trash level information and also the location of the trash bin. And this will save for the cost of implementation, because as a trash collector company, you would have to collect the trash every time, but sometimes the trash bin is not really full that you have to go and collect it. So this will be waste in terms of cost, operational consumption. And the other one is about the enhance the public health. So as I mentioned, the overthrown waste issue would be provide a better perspective on the size of the city, especially in Phnom Penh. So it is also one of the tourism place that is attract for the tourists. And if we have some a bad practice of the waste management or waste collection practice, so this will also slightly affect to the environment of the city as a whole. Okay. So the project can also be impact to the home user or the waste collection company and the mall or public place, as I mentioned. So a proper waste monitoring and appropriate action should be needed in terms of waste issue management, right? Okay, so the expected outcome for this project will be an IoT prototype that it integrates with the waste classification system, as I mentioned, and the waste classification model and data set that we are built specifically for in our country. So we're gonna generate some model that is best for our country. And we are going to also develop a IoT web monitoring platform, a web interface or mobile interface that allow user to interact with the monitoring the system effectively and efficiency. So in conclusion, the integration of the AI algorithm with the IoT would provide a sufficient way of in terms of waste management and monitoring in a more reliable and better efficiency. It also enables the prediction of the waste segregation, so waste type classification, and also this will be helpful for the management in terms of recycling and non-recycling waste. And the solution is a potential to significantly impact the public aspect, as I mentioned about health or cost saving, and also the environmental aspect too. So this is the end of my presentation, and thank you for your attention. So yeah, thank you again.
Are there any questions on the floor? Yeah, there's one.
Okay, so thank you very much. I am Anwar from Telkom University, Indonesia. So actually I am interested in the AI for AI connecting to the satellite. Yeah, so my question here is very simple. The process of AI, it is in the satellite or on Earth?
So
yeah.
Basically, for this, the current plan is we need to get we need to gather the waste, and then we need to pre-process the waste. So the waste classification model, the AI model, will be like deployed at the dump site for the classification. So it's like all the waste will be input into one like small box that have the ability to identify the waste based on the trained model of the waste type and also the material of the waste. So it's not really the on-cloud AI model. So it's just like based on the on-site AI model that can be classify the type of waste. So did I answer your question?
Sorry, not exactly.
Okay.
So I mean like this: if we need to put the process of AI on the satellite, and then it is difficult because sometimes our satellite has already there. So to the best of my knowledge, it is better that you put the process on Earth.
Yeah.
You just take some information from the satellite to the Earth, and you make everything process on Earth.
Basically, we haven't considered about that point yet, but as I mentioned, so maybe we can think about that. So
Okay.
yes, thank you for your suggestion.
Yes, yeah, thank you.
Again, do not take it easy on the model serving, they call it serving.
Yeah.
So really have to look into it. And sometimes you say that you need to be local, then you have to talk about containerization. So if it's not on the cloud, then how you're going to serve it locally, then you have to have another issue. So have a serious thinking about it on the serving side of it. So it's not as easy as a normal deployment. Thank you.
Okay, so thank you for your feedback.
1 more minute. Do you want to take the...
So I think we have similar setting in my hometown, in my province. So the problem is that, yeah, we can classify if if it's plastic or glass or everything. But the thing is that the thing that you put in the garbage bin, maybe there are some thief,
Yeah, that's right. Actually, that's right. Yeah.
And I don't know if you could protect it, but anyway, I think it's a good idea for like when you want to do it. I think it's all the optimization of everything. For example, if you have like the garbage overloaded,
Yes.
and then it causes like pollutions. Of course.
That's right.
And yeah. So it's logistic problem as well. I would like to address that.
Yeah, yes, okay. Thank you for your feedback. Yeah, thank you.
Okay, that's all for this session. Thank you very much for your time.